Hey guys, welcome. We're going to do the Big Mac in New York and West Virginia problem. So let's do it. It says students want to determine if there is a difference. And so that's what they want to figure out, if there is a difference. All right, so this shapes our H sub O and H sub A. They selected 12 in McDonald's and 12 in New York. So this is a big deal. A lot of students didn't realize or didn't even talk about this being here. And the reason why it's here is super important. It's here because notice that these numbers are very small. So this is going to get into the condition. If you didn't talk about it, you lost points. You had to talk about these graphs. Some students talked about graphs they created in their calculator, but that seemed silly because why would you create more graphs when one was already made here for you? Okay, so some kids kind of missed that. This is super important that they put this here for you. They tried to make your life easier. This would make less work for you, okay? So let's dive in. First, the problem says, is there a difference? Okay, well, that's a stat test. That's not a confidence interval. That's called a stat test. Okay, so, and then the next one is interpret the p-value in the context of the problem. So that means you got to talk about Big Macs. Tell me more about Big Macs. And so if you had a textbook, you would look up the definition of p-value. So if you're still stumped after this question, look up the definition of p-value. Just Google it. What is the p-value in AP Stats? What is it? Or type in interpret the p-value. It's going to give you a generic definition, and then you're just going to stick in the word Big Mac. Okay. So let's do it. We got some data, and so let's write out our steps. First, we have data. So step one, we have to go to our spreadsheet, and we have to name. So the first one I'm going to call BMNY, and the next one I'm going to call BMWV for obvious reasons, right? And then I'm going to put in this data set of values. Okay? Now, I then want to do one variable stats and figure out what is, just like the last problem, but I need x bar 1, s sub x1, and n1 I already have. So let's, they already said we selected 12 Big Macs from New York, so I know this is going to be 12. And then x bar 2, we need the calculator to tell us this stuff, and this is going to be 10. Okay. Then, once I have all this summary statistics, it's just going to be exactly like what I did on the last problem in the do. I'm going to retype all that in, and I'm going to get my information, but instead of typing it in for confidence interval, I'm going to type it into a stat test. Okay, so let's do that. Let's go to my main menu, go to my spreadsheet, and I'm going to call this Big Mac New York. All right, so let's put these in. All right, and I put 12 numbers in. So I'm going to go to Menu, Stats, Stat Calc. So Menu, Stats, Stat Calculations. All right. And this is one variable stat. As it stands right now, I only put one variable in. One variable stat. And what did I call it? I called it BMNY. I'm going to select BMNY, Big Mac, New York. Do it. All right. Let's go down here, hit OK. and they did this for me. So this is wonderful. They said, if I scroll up a little bit here, it says X bar is 4.576. So I'm going to put that in there, 4.576. My S sub X is right down here, 0.431, 0.431, and N is still 12. That's how many I had in my sample. And so this should make sense. It says the average is somewhere 4.5, right? And that's the middle of these dots. And it says a typical amount varies by 0.4. So 0.4 would be the distance here. So it's essentially saying a typical dot varies, typical dot varies in width, and that looks about right, doesn't it? That's 0.4 on this graph, and that does characterize the width. Okay, so this is that data right there. Now let's do it again so I can go to any other table here. Let's see, I could just start a new one if I wanted. Go back to on, start a new spreadsheet, call that Big Mac, West Virginia, BMWV. Now I'm going to type in these 10 values. And ditto, right? Same exact thing, one variable stat. There is one list, and this time I called it Big Mac, West Virginia. So this time N is 10, right? I only put 10 in, and there's my average, 4.055, and my standard deviation is 0.313. And so it looks like it's quite a bit smaller. So we think that that makes sense, right? You see how the typical value is around 4 plus or minus 0.3. So a little less variation, a little less spread outedness in West Virginia, and a little bit lower price. But is the lower price just based on randomness? So that's what your stat test is going to tell you. So now let's do our state plan do conclude. But I kind of like to do my do first because I've, done a lot of my calculations here. So I've got my X, all that data right there, right? That's what I'm going to put in my calculator. So go back here to calculate. And I'm doing a stat test. And I have 2 samples, right? And I wasn't given the standard deviation of the population of either New York or West Virginia. So I'm going to do a 2-sample t-test. And I actually have data, but I also already did my summary stats. So I'm going to pick stats. And now here's this information I have. So it's a 2-sample t-test. So what's my plan? We will perform a 2-sample t-test for mu 1 minus mu 2. Well, what is that? It's New York minus West Virginia, right? So this helps us come up with our H sub O, which is that they're the same. And our H sub A, that they are somehow not the same. There's nothing in my problem that says that I should think that one is bigger than the other. So this is a 2-sided test. Okay. Now we would presume, and also looking at our data, that New York is more, but they didn't give us any indication to presume that one was bigger. So I'm just going to proceed with the 2 test. All right. So let's put in the data that we created a minute ago. And I'm going to keep this as the alternate hypothesis as a 2-sided test. And there we go. I get my p-value. So doing my do here, What did the calculator do to create this p-value? Well, this is a t-value. So it takes these two values, subtracts the two, and compares it to 0, because there should be no difference. That's H sub O, that there is no difference. And then it puts it over this cumulative standard deviation. Right? So if I look at the numbers put in, did I get a difference? So my calculator says, well, yeah, you did get a difference there. Well, what difference did you get? So if you subtract these two by hand, I get a difference of, it looks like about 1, 2, 5, right? Okay. Now you're thinking, well, why did I do this? You don't have to do it. It helps you get the multiple choice questions right, and it helps you understand what's happening in the problem. And it helps you appreciate the fact that the calculator is doing a lot of the work. So it created a t-value of 3.28. Well, what is that? If you go to table A, what is the probability of getting that at least as large? And that's going to go into this next part of the question. What is a p-value? So if you go to table A, and we're doing a two-sided test, what would be a negative 3.28 or a positive 3.28? What is the area under the curve to the left and the right? And that's technically what the p-value, how the p-value is created. It's not what it means. And so but it is how it's created. So the p-value is this area under that curve, and it's saying that the area under that curve to the left and the right adds together to make 0.003. Actually, 0.038. All right. So what does that mean? It means since it says at the level of 1%, that wouldn't have mattered either way, but since our p-value is less than alpha, which is 0.01, we reject the null hypothesis. We do have sufficient evidence to support H sub A. What is H sub A? That to support that there is a difference in Big Mac costs in New York and West Virginia. All right. Now, interpret what p-value means in the context of the question. Very important here. How would we answer that question the most accurate way possible? Well, what they're saying here is p-value means if there truly was no difference in Big Mac value of New York and West Virginia, there is a probability, that's why it's called p-value, of 0.0038 chance of getting a sample this much of a difference or greater. So we definitely got a difference, right? And because we got a difference, that was an fairly extreme difference. And so if we assume that there is no difference in Big Mac value between the two states, then this would be the probability of getting a sample this much of a difference or even greater of a difference. Thanks for joining me, guys. See you soon.